Okay, so before moving on, what was wrong in the previous example when I wanted to show you something like this? Well, now I fixed the code. So, I mean, you add something and we trigger an error from the server side and we need to display the error. So click add, okay? This is shown here, it was green, okay? So the optimistic update then disappears when it refreshes. And you see the error question not found, okay? This is just a console log just to show you something. And by the way, you see this line 404 in red in the console. You cannot do anything about this because the browser decides that in this console, everything which is not to 200 or something prints it in red, okay? So, I mean, just because I said, I mean, I don't want to see errors in the console, but of course errors generated by your code, okay? As actually I was doing before, because the problem was that I was calling the handle error, but the handle error was not defined, okay? So I forgot to copy paste this handle error that we saw in the beginning, but from the solution. So if I save it, and I do the same operation again, okay, add, you see, of course it didn't work, but here we had something in the console. So I did a mistake that, I mean, many of you do in the lab. I mean, don't open you don't open the console or the network tab, so you're not able to debug what's happening. I was looking at the network tab, okay, we got the answer, and then I thought, well, we should see the error. But actually I didn't look at the console, okay? The console was saying, handle error is not defined. Of course, I mean, we forgot to write it. Now it's been written, and a little bit more modification were necessary, because like in the add, we had to add status added to show it in green for the optimistic update, okay? And this is just after the user clicks the add button, and then there is the refresh, and the handle error goes and set the error message, and of course we need to set it somewhere. So we need to define the error message as state, but this is standard stuff, and then show it somewhere. This is the answer route, and we want to show it somewhere, typically with an alert. That's the easiest thing, okay? Dismissible on close, you put a callback that resets the state, so it make it disappear. Okay, so let's test it one more time, and then that's all. I already committed the what we did on the GitHub, so ABC, and then in the office I will remove the error, so you can test the code without the errors. So you will see the new answer in green for 1 second, and then it will disappear. Okay, click, you see, and it disappears, okay? So it's sort of an indication for the user, it's temporary. Maybe you don't like the green, you want to show everything in yellow, maybe in gray, grayed out, whatever you want, but you see the error as well here, okay? Question not found, it stays there until the user clicks on the X. That triggers the on-close event on the alert component, and where you have the reset of the React state. And that's in general good, because you give time to the user to read the error, okay? Not all users are fast or quick enough like you, or like hopefully me and so on, to read these errors. I mean, think about old users, old in terms of age, right? And it takes some time to understand what's happening in the interface. So if you allow the user to read the error and reset the error, okay? That's fine, okay? And by the way, this system should work also if the user doesn't click on the X, okay? That would be great from the point of view of the user interface, okay? But, I mean, that's just another possibility. I mean, some users like to make the errors disappear because they want a clean interface. Other users don't even care, okay, after they read it. Okay, so that's all from the point of view of the application, and we basically have all the things that are necessary for developing lab number 12, okay, next week. Complete API integration from server and client, so add, edit, delete, and also if you can, also do the edit inline. It means actually you don't have a separate page, like for the delete. Okay, clicking on the favorite, it sets the favorite on the server. Clicking on the rating, the stars, it updates the number of stars on the server. Okay, not so much different from the delete action. Simply you refresh the content and something doesn't disappear, but it gets updated. Okay, good. So let's go on and move to the last topic of this course. It's a big topic. It takes more than 1 week again to discuss. But I mean, we cannot do without this because web applications are multi-client by default. Okay, and typically when you have multiple clients, you want to associate each single client to a user. Okay, and you do it with username, password, and all this kind of stuff. So we want to discuss this point here. Okay, so a need for authentication, of course, and so on. Who are you? Authentication. So first of all, don't mess up between authentication and authorization. So there are two different things. One thing is who you are. It's about your identity. Okay, username and password are the typical way in which you tell the system who you are. Okay, they call them credentials, username and password. Okay. Of course, allows a personalized user experience because the application, the system recognizes me and shows me only what is relevant for me. Okay? Authorization is a different thing. Okay? So once they know it's me, or in general, they know something about the user, before providing information, allowing action and so on, the system must decide if the user who is making the request is authorized to do the action or getting the information and so on. Okay? And this might be a separate issue depending on who you are or in general the information you present to the server for asking for an action. Okay? So authorization is about to decide if you, or, I mean the request has the permission to access a resource. Okay? Typically, the authorization rights depends on the identity, so it's easy to how to say to swap one for the other, but it's wrong. I mean, authentication is about who you are, and associated to who you are, typically there is a set of permissions. Okay, like you are a normal user, you are the administrative user, so you can do much more actions typically. Or maybe you are just a guest, so you are not recognized as a user with a certain username and so on. So a set of actions is available, others are not. So it's not mandatory to have authentication before authorization. Simply the authorization is a process that determines what you can do on the server depending on the kind of request or the things that you send to the server. Okay? Okay. Often used in conjunction to protect access to a system, and this will be our case. Of course, you could expand this topic much more, okay, like talking about role-based access control or stuff like that. I mean, systems that can, decide which level of authorization you have depending on the authentication, or having more final granularity on this authorization system. So it's not just related to who you are, but the moment in time you are, what you accessed before, and many things. Okay? But the point is that one is recognizing who you are, and the rest is what you can do. Okay? The permission to do something. Access, modify, and so on, the resources. Okay. Of course, this is a complex topic. It's complicated. It's time-consuming. Unfortunately, it's very prone to errors. Many security vulnerabilities happen because you did something wrong during the authentication or authorization phases. Okay? So you didn't do some checks, for instance. And that's the thing that we will check a lot and we will care a lot about during the exam. Okay? Because, I mean, we are from the cybersecurity course of study, we need to take these things right. Okay? Maybe not 100%, but at least you should have thought about this. it might require interacting with third-party systems. You know that you can log in with Google, you can log in with Meta, with Facebook and whatever, GitHub, etc., and then access information on other websites. So there are a lot of things that gets exchanged between different websites and so on. I mean, we are not going to cover this also because there is another course that is going to cover these topics. But I mean, in general, it can be quite a complicated situation, okay? It involves both client and server and requires to understand several new concepts that we will discuss in a few minutes today and next time, okay? And this is, it's much better if you rely upon best practice and standardized processes. So don't invent anything, for sure. I mean, not for this course, not when you get your degree here. Maybe one day after you have a lot of experience, and typically you're not alone, you're in a committee drafting standards about security, authentication, and so on. All together, maybe you can come up with something new that is more or less reliable in terms of security, okay? Nowadays, I mean, it's almost impossible for a single person, I mean, designing something which is good and resistant, resilient, and so on, okay? So it's better, it's sort of mandatory, I would say, at our level that we rely only on best practices and standardized process. We don't invent anything. Okay, just to give you an idea of the complexity, that is this table that tells you, the various layers of authorization, not authentication, authorization, okay? So let's say the user does login, logout, so it's authorized to log in and log out and navigate to some pages and so on. In the React, you need to keep track of this information, and the browser has to remember this information. We talk in a minute about sessions, cookies, and so on. The server has to remember this information as well, so this session data, etc. And there is a lot of checks you need to do on the server side, because you need to check things at every HTTP request you receive for non-public API. So, of course, I mean, if information is public, it just get information. I mean, it's no check you need to do. But I mean, if you need to, you want to modify something, you want to, like before, we were adding adding a new answer. Actually, I mean, it was anybody could add, that's fine, but at least we had to do a check. It was not really authorization, it was consistency, but we had to check that the ID of the question existed, right? So there are a lot of checks that have to be done on the server side, and especially from the security point of view, okay? Okay, login time, logout, and so on, and also the database, okay? We need to store the sensitive information like password, etc., and we will discuss how to store them in the best way, okay? Okay, so first of all, giving memory to HTTP. Cookies and session, I think this concept should be already known, at least partially to you, because hopefully in the network course you already talked about HTTP, and you know this HTTP protocol is stateless. What does it mean? That you do a request, and the request gets an answer, and the question and answer couple is independent from the previous ones and the next ones, okay? That you can do to the same server from the same client, even on the same port, okay? HTTP, HTTPS port, and so on, okay? So each request response couple is independent and must be self-contained. Okay, because the HTTP protocol is not meant to remember previous requests. Okay, it's not like TCP. TCP is a connection, so it has a state on the server. Indeed, it takes the resources on the server because you need to remember the fact that you already opened a connection with some client at a certain port and so on, and you need to know how many packets are being transmitted, received, acknowledged, and etc. etc. That's a session, right? And HTTP is not, it doesn't work like this. You have a request and you get a response. And that's all. And you don't have to remember anything from previous requests. Unless, of course, you have the need for doing this, but this is external to the basic version of HTTP. Okay? Because in a web application may need to keep some information between different interactions. Okay? So, like on the Polito website, Didattica web portal, I mean, for your for your career, you go there and you identify yourself, so you give some credentials, username and password, and then you can operate on the data of your career and so on, adding courses, removing courses, looking at the marks you got on the courses, etc., etc. But it's not like at every request, every click you do, you need to send again the credentials, okay? It doesn't work like this. I mean, there is something that goes from the client to the server because each request is supposed to be independent, but there is some special information that goes from the client to the server to allow you to keep together different requests, even though you don't provide anymore the credential after the first step, okay? Just a few examples. I mean, I just did an example, but like in online shop, Amazon.it, whatever you like, you put a book, you put an item in a shopping cart, and then next in iterations with the same website, remember that you have an item in the shopping cart. It doesn't get reset, right? So something is stored there, and next requests don't tell the website that you have this item in the shopping cart, even though it's not saved on the database yet, okay? We're not talking about saving on the database. Of course, if you save on the database, things becomes permanent. But I mean, the point is here that you can maintain a state on the server, also if you don't store it in the database, okay? So we want our state to be remembered while we navigate through the website, okay? Or just to give you another example, you make the theme of the website dark or light, okay, white or black. I mean, this is not an information that maybe you want to store on the server because it's just temporary, but you need to remember this. Otherwise, next time instead of the black, you get a white page and so on. Okay, just a temporary state. That's what we are talking about at the moment. So actually, this leads us to the concept of a session. A session is a temporary and interactive data exchange between two or more parties. Typically, there are two parties. Okay. In our example, there are two parties. There's the client and there is the server. Okay. Concept is more general because you can have sessions for protocols that involve many parties, etc. But that's not the case of HTTP. HTTP is just one client and one server talking together. It involves one or more messages in each direction. Of course, often one of the parties keeps the state of the application. That's typically the server, but not only the server. You can have a state on the client as well. Okay, and indeed, what we are doing in React, we will have a state on the client as well. Okay, it is established at a certain point in time. And at a certain other point in time later, it might end, okay? Typical case, at a certain point you log in with the username and password, you start the session, and at a certain point you log out, you press the logout button or something like exit and so on, and you end the session, okay? Like with your bank account, with whatever website you might think of, your email, web-based email and so on. Okay, how do we maintain a session? How do we create a session with HTTP? Well, we need a session ID. What's an ID? Just a value, a special value that uniquely identifies the session. So, basically, upon authentication, it's not authorization, this is authentication. So you provide a credential, username and password, and the client receives from the server a session ID. Okay? Only the server can create a session ID in this in our configuration. Okay, so the session is something that has to be established by the server upon receiving some credential information, typically username and password. Okay, this session ID allows the server to recognize future requests sent by HTTP as part of an authenticated session. So a session for which you performed an action, typically authentication at the beginning. Okay. So in short, this ID will be sent from the client to the server every time you have the session active and you need to perform an action that requires to have this session active on the server. The session ID must be stored on the client side because you need to send it at every request. It has to be stored somewhere on the client side. It means in the browser because the client for us, that's a browser. It must be sent by the client at every request, which is part of the session. Of course, for public APIs and so on, we don't care about the session. But if it's an API that needs to have a session active, like give me the list of marks for my exams, I need to send the session ID. Otherwise, the server doesn't recognize me, and it will not provide the information, or it will not provide my information. Okay, just generic information available to everybody and so on. It must not contain sensitive data. This is important. I mean, of course, creating a session ID is easy. You put username and password inside the ID, you have a unique session ID. But that's not what we want, right? Because, this session ID is a sensitive data in the sense that if somebody managed to have a look at what's stored inside the client, if it's sensitive information like your username and password, it can use it to create new sessions, right? So we don't like to have a session ID that contains sensitive data. Data must be opaque. So, it means there's nothing in clear text that can be easily understood, okay? Okay. Because it is readable by the client. We will see examples, okay, with the inspector as usual, okay? So I have nothing to show you at the moment, but in general, by the way, it's not nice to show session IDs when you're recording stuff, but for the application later on we will see it. So it's readable by the client in the sense, that you can look in the storage, in the file system, or maybe in the inspector in the browser and so on. As long as it's you, that's fine, but anybody can open the inspector in the browser. You leave the computer there, nobody's looking at the computer, another one comes in, have a look at what's inside your computer, and just clicks on the inspector in the browser and reads your information, okay? So it's better that it doesn't contain information that can be easily copied and stored somewhere else. Must be protected from eavesdropping during communication. So if somebody managed to get this session ID, well, it can act as if it were you, so the one that did the authentication. That's why all request that goes to the server that contains a session ID must be sent on a secure connection, means encrypted, okay? Because we don't know what happens between our client and the server. Of course, now, today, in the course, we are playing on localhost, so, this issue is not it's not an issue for us, but also we are playing with demo applications, so it's not a problem. But you are sending requests from your client in the internet somewhere, we don't even know where, until you reach the server. And anybody who has access to the communication links or the devices, the routers and so on, and can see the traffic passing, can read the information if the protocol is simply HTTP without encryption, right? And if it can capture the session ID, it can use it immediately and send other requests to the server. So we don't want this to happen. And so basically, it means that the session ID must be protected from eavesdropping, if you like it, wiretapping, if you like another term. So people looking at what is the traffic that is passing from server to client somewhere in the internet. And of course, it must be difficult to guess. Okay, the server can just provide a session ID like number 1, and the other number 2, number 3. Okay, I know the server works in this way. Well, I just try a random number. Okay, It's true. I mean, there's no sensitive data. It's protected from eavesdropping and so on, but can be guessed. It's like when you use the password 123456. Okay, websites don't like when you set a password. You set an easy to guess password because I mean anybody can try to guess these passwords, right? If it's a random string, a long random string, that's much better because I mean you cannot simply guess it. Okay. Okay, good. And in our web applications, once we have this session ID, it will be typically stored in the client, in the browser, and sent as a cookie. Okay? Because HTTP recognizes that having this request response couple isolated from all the rest of the requests in the communication is a limitation. So it designed a mechanism to keep together different requests. And these different requests are kept together with this mechanism based on cookie. A cookie, well, I think there is a slide, yes. A cookie is a small portion of information inserted in the HTTP header. So some information that goes back and forth from the client and to the server and vice versa in HTTP headers. What are the HTTP headers? I hope you remember them, right? I mean, these are the headers. Option has no headers. Headers. You see, these are the headers, right? Response headers, access control allow origin. We saw it last time. Course headers and so on. Or request headers. Okay. Now we don't see any cookie because we don't have the cookie. But once we finish the discussion, we try an example. I mean, not today probably, but we will see cookies going on. And they are so important. There is even a tab here in the inspector just to isolate and show the single cookies, okay? Because they are so important. Okay, good. These cookies are automatically handled by the browsers, okay? So the browser automatically stores the browser cookies, the cookies in the browser cookie storage. So there is a separate piece of memory in the browser that manages this small set of information. So let's say small strings, few hundred characters, something like this when they are big, and they are put inside the storage of the browser. Okay, and moreover, they are automatically sent by the browser to the server when performing a request to the same domain and path that originally sent the cookie to the browser. Okay, note that the port is not included, it's just the domain plus the path. Okay, domain and path, not the port. Okay, that's a limitation. Maybe nowadays they would have done things differently, but that's what's written in the standard. So that's how cookies work. Okay, so it means that when you make a request, an HTTP request without a cookie, the server decides that it can establish a session, so it wants to do it with a cookie. It sends back a cookie to the browser with a special header, set cookie, we will see it. Set cookie with a value, actually key plus value, and this key plus value will be stored by the browser, and the browser will send it back to the server every time you do a request from the same domain and path. So it's not like the Polito sets a cookie and it's sent back to Google, okay? And it doesn't work like this because the browser knows that the cookie belongs to Polito, so it only sends back to Polito when you make a request towards Polito, okay? So the university website. Options are available to send them in other cases, and by the way, we will use them because we have this course issue. So we need to be able to send the cookies sometimes to other places. Okay, but typically we don't do it. Never store sensitive information in a cookie. So as I told you, a password, a secret, etc., because they can be read by the client, browser users, anybody who has access to the browser. Okay. Okay, good. Some attributes of a cookie. So cookie is a special piece of information because it's not just a string, okay, but it has some attributes. So there is a name, that you can decide for your cookie, and the value. These are the two which are mandatory. Okay, like session ID, you call it session ID, and a value, typically a random string, quite long random string. Okay, why you can set name and value? Because so in this way you can have multiple cookies for the same website and same host name and same path. Okay, so it's just a mechanism to allow you to have more than one cookie for the same server. Okay. And there are other attributes, like the secure option. If said, the cookie will be sent to the server by the browser only if you're using an HTTPS connection, so HTTP protocol over TLS nowadays, or SSL, so the encrypted TCP connection, so it's protected from eavesdropping. So just in case, I mean, this is just I would say an advice, an indication for the browser to avoid sending the cookie if the connection is not encrypted. Okay, so just in case you have you do a mistake or in the programming of your application, or maybe somebody tricks you into accessing some servers without using encryption, the browser will not send the cookie. Okay, so you're sort of sure that a browser will not try to send this cookie in case the connection is not encrypted. The other option is much more interesting. We will come back to this. HTTP only, it's a Boolean option like the secure option. If set, the cookie will be inaccessible to JavaScript code running in the browser, even if the JavaScript code comes from the same web server that set the cookie. Okay? This is important because, I mean, there are so many exploits that can target cookies and can try to read cookies using JavaScript and so on. At a certain point, I mean, people developing the HTTP standard decided, well, maybe let's just make the cookies inaccessible to JavaScript. Of course, that's a configurable option, has to be set by the server when it sets the cookie in the beginning. But, I mean, in this way, no JavaScript, including the JavaScript served by the same server, can access the cookie. So it's entirely managed by the browser, and nobody can access it. Okay? And then it has also an expiration date, because sometimes, I mean, you want the sessions to expire automatically after a few minutes, 10 minutes, hours, days, months, and so on. Okay? Like something that expires automatically. I mean, actually, this can be enforced only by the server, but it's convenient for the client as well, because if it says that the expiration date has passed, the browser can simply discard the cookie. So it can free the memory. Otherwise, you keep accumulating cookies, which are basically useless. And it's just a mechanism for the browser not to keep information that is no longer relevant. Okay? Okay, so name value. We need to establish a name and a value. And then secure, decide if we want to use the secure flag. Typically, yes, but unfortunately, in our applications, in our demo application, only for this course, only for configuration simplicity, we will not use HTTPS and we will not use the secure cookies, okay? The secure flag for the cookies. Just for convenience, because setting up HTTPS means we need to create a certificate. Since we don't have a certification authority, it has to be self-signed, or if we really want a certification authority, there are some free ones that can sign your certificate, but then you need to have a web server exposed in the internet with your code and so on. So many complicated things that we don't want to address here, okay? Just for simplicity, because we are focusing on how the application works, interaction between client and server, protection, security from the point of view of the designing or programming of the APIs of the client, and etc. Okay? This is quite standard stuff to use. I mean, you can even ask AI, how do I set up a server with HTTPS and so on? I mean, just decide where you want to deploy it. You want to serve a certificate, you want to sign a certificate, okay, ask that one, the other one, and pay the amount they want, and so on, okay? But, I mean, it's really sort of trivial stuff. So it doesn't add anything to our explanation, so we are not going to use it in this in this course. Okay. Okay, so let's come back to the cookies. How do we use it to create an authenticated session? Here you see the interaction between the client, which is the browser for us, and the server. So at a certain point, we need to send a request that contains the credentials, username and password. Okay? We don't have the cookie yet because we're just accessing the website as we did until now. There is a form. You can type the username, the password. We know how to program forms. It's like the add form. Right? We will create a new form for authentication with the username and the password, and we send a request. With the post method, actually, because, I mean, it's not idempotent, it creates something on the server. Okay? So it will always be a post request. It's wrong to create a session with the get request. Okay? And the other ones, of course, it doesn't make that much sense, right? Put or delete. There's nothing to update or delete. So you send the username and the password, and the server decides if it wants to create a session or not. If the username and password are correct, so it corresponds to something that is recognized by the server creates this session ID. Okay? And this session ID is sent back as a cookie, so in the headers. Okay? It's not data sent in the body, but in the headers of the post response. And then the browser stores it, because the browser processes all the headers that it can see in the response. So it says it can see set cookie. Okay, there is a cookie. Take it, store it, associate it with the web server that gave it to me. Okay. And then we make requests to the same web server. So same host and same path, we said. I mean, same initial part of the path. Maybe just slash was set by slash, that's fine. Okay? And the server, the browser, we said, automatically send the cookie. We don't have to do anything. Indeed, if the cookie is HTTP only, we cannot do anything, because it's managed by the server and it is inaccessible by JavaScript. That's good. And the server receives the cookie, the value of the cookie, name plus value. It checks if the value is valid. If it's valid, it does the operation which is requested, and it gives the response. If it's not valid, simply says, okay, it's not valid. I will send back another HTTP status, typically 400 something, unauthorized, etc., and it will not give the information back to the user, or it will not perform the action that was requested, add, delete, edit, etc. Okay? So that's the system, how the system works. Okay? So first, with the credential, you create a session, and so you establish an authenticated session. The server may associate something with the session as well, but we will come back to this later. And then you use it, okay, until the session expires. So it means that the session is not recognized as valid anymore by the server, okay? Okay, security tips in general, but not for our case in this course. As I told you, always use HTTPS and the secure option in cookies, at least in production, and always use HTTP only option in cookies. Okay? Never store sensitive information in cookies. So if you decide, I mean, if you are the one that programs what is contained in the value of the cookie, I mean, never store sensitive value there. Okay. We will use a framework, so somebody else will decide what to put in the cookie for us. Okay? And that's good in a certain sense, because, as I told you, it's better not to reinvent anything, but just rely on good practices. Okay. Okay, so that's what I wanted to say. Some security advice. We are in a cybersecurity course of study. We try to, have a lot of attention to this aspect. Always rely on best practice. Avoid to, we say, reinvent the wheel. I think in English you can say it as well. Okay? So, I mean, you don't have to re-implement anything again and again and again. The only thing that can happen is you do it wrong. Okay? So just use something which is reliable. Okay? Because web applications are exposed to many attacks. We already saw them, some of them, like cross-site scripting. You remember the cross-site scripting? Attackers inject malicious JavaScript code into web pages. I just show you the alert act. You remember the alert act window I showed a few weeks ago? I could have done inside the browser and read the cookie, okay? If there was a cookie, actually there was no cookie to read, so I didn't do it, okay? But I mean, if it's accessible by JavaScript, you can do it, okay? I think it's document.cookies or something like this, a property inside the JavaScript environment in the browser. But if it is HTTP only, no JavaScript code can access this cookie, okay? Regardless of the source, okay? Not even the original JavaScript application code can access such cookies. But we don't need it. The browser sends it automatically. That's all. That's enough for us. Another typical attack is the cross-site request forgery, when a user is tricked by an attacker into submitting a request that they did not intend. Okay, with the browser. And the problem is that all browsers in the world automatically send the cookies to the server, regardless of where the request started. If you click on a link in an email, if this link opens the browser, you have an authenticated session active, the cookies get sent to the server. That's a problem, right? So, I mean, in general, we should avoid these conditions, okay? There are mitigation systems to avoid, to limit the damages of this kind of cross-site request forgery. Like you get a link from an email or from an instant messaging system, WhatsApp, whatever, you click on the link and you open the browser and you send the cookie, okay? There used to be much simpler ways to handle this situation. So, I mean, if the request didn't start from the JavaScript, you don't have an additional header that is called CSRF token, etc. But since there are, attackers are always trying to find ways to circumvent this protection mechanism. Basically, nowadays, when you do critical operations, they ask you for a second factor, right? Second factor, you need to send evidence of the fact that you are authorized to do this operation using a second factor that is the last topic we are going to discuss in this course, okay? But before going to that point, before arriving to that point, we need to understand authentication and basic authentication. In general, proper usage of what is commonly established as goods, so frameworks, best practice, libraries, and so on, it can already prevent many attacks. Okay, many problems comes from the fact that you use, custom design mechanism, authentication mechanism, not using the frameworks in the way they were designed for, etc. So, okay, so try to stick to the standard solutions, standard ways, and if you need to deviate, always ask yourself, before doing anything, is this correct? Do I really need to do this thing differently from the example, what is recommended and so on? What are the implications, etc.? Maybe you can even ask for advice from colleagues more expert than you and so on. Okay, so let's come to the practice. So we have React on the client, and we need something on the server. We need a framework on the server. We don't want to implement everything from scratch. It will be possible. We can access headers of the HTTP request and so on, but we don't want to write code except what is needed to decide how to handle the session. So what do we want to put in the session and so on. But the rest should already be ready. Okay? And we decided to use a library which is called Passport for the server. Okay, so we're going to discuss a few more things before we go and see how to implement this with the code. Okay, so basic flow for login. Okay, that's the basic operation. We said we need to provide credentials to establish an authenticated session. How do we establish a session? The basic system is asking for username and password. Okay, so a user fills out a form in which the client, with a unique user identifier, that is the username, often an email because it's unique in the world, okay, but it can be the mobile phone, it can be any ID that is given to you by the server when the user is created, okay, and the password, which must be kept secret, of course, okay. The data is validated on the server, so the server checks if this password corresponds to the user, if the password is still valid, etc., with the post API as we saw before. The server received the request, okay, sent to the server with the post, and then the server received the request and checks whether the user is already registered, so the user exists, the user has that password, and the password match with the one that has been provided by the client, okay. We will talk about how to check the password, how to store the password in a few slides, okay? Because this is a really important topic. If the user does not exist, or the password doesn't match, or there is any problem, I mean the user is in a state that cannot log in at the moment because it has been temporarily disabled, whatever, the server says, okay, no, I cannot establish a session, okay? And when you send back this information to the client, make sure you don't leak any private information, any information about the state of the user and the password and the system and so on, okay? So the answer to a failed login attempt should always be login failed, okay? If you really want to write something more, invalid user ID or password, okay? You shouldn't say, this user is temporarily disabled, okay? It gives some more information to the attacker. Invalid user ID, it says, I mean, this user ID doesn't exist. Try another one to an attacker, okay? Login for user for invalid password. Again, it says the user exists, okay? Login failed, account disabled. We don't like to tell information about anybody. Anybody can submit usernames and password. Anybody from the internet, from the world. This user is not active, and so on, okay? So at the exam, you will lose points in case the answer is not simply invalid user ID or password, or something similar that doesn't tell anything, okay? Login failed, that's fine, okay? Because we don't want to give information to the attackers, okay? Otherwise, if you say just, invalid user ID, that means that you should try another user ID. Maybe you are trying to guess user IDs, okay? Maybe you have a password and try to guess user IDs and so on. Okay, so this is very important. I mean, not so difficult to get it right at the exam. You just copy paste from the examples we give to you, and there's no need to modify it, okay? Because logging with username and password is pretty standard functionality. I mean, there's nothing additional that you need to do. Okay, username and password are correct. Okay, let's go on. Server generates a session ID, okay? Typically, the server creates the session ID, creating a random string. The server stores the session ID together with some user info retrieved maybe by the database, at least the username, because it must associate the session ID with the user that did the login. Otherwise, when you get the session ID, you don't know which user did the login, okay? So that's a minimum. You need to have the username associated with the session ID on the server. And then you can also associate other information. I mean, depending on what you want to associate, you can do whatever you want, but as long as you have the information, the connection between the session ID and the user, it's fine. Because through the user, you can retrieve all the rest of the information if needed from the database on the server side, okay? And then the server replies to the login HTTP request, so to the post, by sending the cookie, okay? With a certain name. The name is decided typically by the framework. We are going to use a framework. I don't remember what's the name of the cookie, Okay, they just use the same name. It's a key with a value, and the value instead is the generated session ID with the options in case. Okay, HTTP only true, secure true, only if it's sent over HTTP. Of course, it doesn't make sense to set true of the secure if the response is sent back on HTTP. But personally, I would avoid servers that do authentication over HTTP, right? Because you are sending the credential, username, and password over HTTP, and so they can be wiretapped or eavesdropped, again, like the session ID, right? So, I mean, typically you log in on a server using HTTPS, so on a encrypted connection, okay? Otherwise, there is already something wrong with this server. Or either they don't care about security, or I mean, there's something wrong going on. The browser receives the response with the cookie, and then the cookie is automatically stored by the browser in the browser cookie storage. Automatically, you don't have to do anything. No line of code. By the way, if it's HTTP only, you don't have access to the cookie as well. Response body is handled by the web application, okay? Since it's a post request, it can have a body, and you can send back information in the body. For instance, typically, you have a username and password, you can send back to the application, first name, last name, and so on. Hello, Enrico, and so on. Where is the first name coming from? From the server, from the answer to the login. That's fine. So you don't have to make a second request with a session ID to tell me which is the name, first name, and last name of the user, and so on, okay? So you can already use the post-transaction, HTTP transaction, where you perform the authentication to send back information from the server to the client. That's fine. Okay, and that's what we are going to do as well. Okay, in practice, we have React. We know how to program a form. Actually, a login form is actually a normal form, a standard form. For React, there's no difference between a login form and a form where you can add the answer, add the field, and so on. And login form, you have two states, username and password, two fields. So, oops, they are not shown here. Anyway, input type text, name, username, value, username. Input type text, name, password, value, password. Okay, normal. I mean, a standard text-based boxes in the form where you can type anything. Often with the password, you write type password because in this way the browser automatically doesn't show what you are typing, but it shows these dots or X or with the stars and so on. So, I mean, people overlooking you that you are logging into a website that cannot read the password that you are typing, okay? But that's just for convenience for the user, okay? But it's not like you are protecting any, it's just not showing things in the user interface, okay? And then you perform the login, okay? Remember, if you have a form, you have a submit button. The submit button can be the login button. Then you generate an onSubmit event. This onSubmit event calls the callback you registered in the form and on the onSubmit event handler. And first of all, in React, you need to do prevent default. Don't submit anything through the browser to the server. This is a single page application. We do the submission by ourselves. How? Well, through some function that will take, of course, username and password, and it will issue a fetch to a certain URL with options, method post, okay? And we will see credential include because it's needed to establish the session and so on. But anyway, so it's just a fetch, like any other fetch towards the server, okay? Standard form, when you finish, you have the submit button, like you send the data to add the answer, to edit the answer, to add a field, to edit a field, just send the information to the server to an API endpoint that is in charge of checking username and password and send back the session ID, okay? Plus any other information I was saying before, like first name, last name, and so on. Okay, so what do we recommend for this course? And by the way, many websites use it. There is a library which is called Passport.js that works very well with Express. That is the server we are using in this course. Okay, in the Node environment we have let's say a nice to program HTTP server, and it's very flexible and modular. It supports 500 plus different authentication strategies. We only care about one. That is the one with the username and password, okay? But, I mean, you can use it to extend it, I mean, not extend it, you can configure it to use any kind of authentication you might think of, okay? Even with Google, Meta, and so on, okay? GitHub, etc. So they implemented the protocols needed to exchange some information with those servers and get some response back from those servers telling, okay, the login has been successful or not, okay? And plus some other, I think, user ID, etc. Okay? But this is outside the scope of this course, unfortunately, or fortunately, not sure, okay? But there are other courses addressing this in the course of study. Passport is also able to adapt to different type of database, but actually we're not using database connected with password. We're just keeping the sessions in memory, okay? Just for convenience, again. I mean, we're just testing things. So we don't want to have too much complexity on the server side, okay? A serious website typically stores the session information in a database because in case you have to restart the server, you don't lose the active sessions. If you keep everything in memory, when you restart the server, everything is deleted. It means every user has to re-authenticate. If you have a couple of users, it's fine. If you have 2 billion users like Facebook, that's not good, right? Okay? So, and then we like Passport because it adopts some best practices under the hood. It means automatically without us doing anything. Okay? For instance, it set the HTTP only flag on the cookies for the session, okay? So unless you disable it explicitly and so on. So it's reasonably good for our purposes. How do we configure the passport? Okay, we need to first choose and set up which authentication strategy we want to adopt. So we will say we want to adopt a strategy that uses username plus password, and maybe we need to use some additional middleware. There will be one that we need because we want to establish session, not just performing the authentication, and decide what we want to keep in the session. Okay, so these 3 things. And we will see now how to do this. Okay, yes. I mean, I will say very quickly, and I want to point out one thing that comes a bit later in the slide, and we can come back to this these slides next week when we see the example. So we read the slides and then we can have a look at this example immediately. Okay, so we need to use this local strategy, which is the one that can take these 2 values, username and password, and we need to provide a callback as in any JavaScript code and so on. But again, I mean, there is a function we need to define just to make sure that username and password are correct, because it's not inside password. It's up to us. It's up to us to write code to check in the database if the username and password, actually, the user exists and the password matches with the user. Okay? What I want to tell you, so you have a little bit of time to reflect on this, to think about this, is that you should never store plain text password in the server, in the database, and so on. Even if it's a database, even if it's encrypted, whatever, and so on. Okay? Always perform password hashing, which is not encryption, it's hashing. Hashing is a one-way function. if you have the hash, you cannot go back to the password, okay? It also means that if the user has to reset the password, it doesn't remember the password, you have to reset the password. That's why I would say most of the websites, hopefully all websites around the world, when you forgot the password, they tell you, set a new password. If they tell you which password was set by you, that's a big warning. Probably something is not good in terms of security for that website, okay? They shouldn't have your password in clear text anywhere, okay? They should have hashed the password, okay? So you can store the hash, and if you store the hash, it means that not even the managers of the website or the people, the administrators of the website knows which password corresponds to which users, okay? Not even a single password, because otherwise they could be tempted to use them, right? That's not good. Maybe they are the best people in the world, but I mean, if you have no chance, that's better, okay? To be bad people, to become a bad person, that's better. But in general, it's not really about administrators. It's more in case your data is stolen, okay? So it's copied by some attackers. If you have hashes, I mean, you need to guess password, because hashes cannot be decrypted. It's not like the password is encrypted, I find the key and I can decrypt the password and get all the password in clear text. That's not the way it works, okay? Good hashing is impossible to crack, but the point is that password can often be guessed. And that's why websites typically tell you, use at least one number, one uppercase character, one strange symbol, and so on, and so on, and so on. Because they don't like that you set password like this, like 1, 2, 3, 4, 5, 6, QWERTY, password 1, and etc., etc. Okay? But actually, they can only check this. Well, on the client side, that's a good point to check when you set a password. With JavaScript, you can do these checks. And then that's a problem, right? Either you, the first time you send this password on the server, and so you have it in clear text, you do the checks and then you store it on only with the hash. And so you trust the checks, or you do the checks only on the client and you opt for the best, okay? Because then the user could have sent anything to you if they send the hash, right? When they receive the password, also just to verify the password, simply they get a password from the client. So you log in, username, password, you get a password, they do the hash, and they compare the hash. Okay, hash is one-way function, and it's deterministic. So if you start from the same input, my good password, exclamation mark, you always get the same hash. Of course, if you use the same hashing algorithm, okay? Okay, that's good. And you store the hashes, and that's fine. But you see the example here, okay? Just quickly, and then we will come back to this next time, next Monday. You see what happened? There is somebody that used the same password twice, okay? No, I mean, two different users used the same password. And actually, if you only use the hash, you see the hash is the same, right? They use the 1, 2, 3, 4, 5, 6, but it can be any string. The hash is the same. That's not good, right? Because it's true. You don't have the original password, you have the hash. But the hash is the same, means the original password is the same. And this typically happens when passwords are weak, okay? Because the users, they typically set this kind of password like Politecnico 123, I don't know, like these kind of things. Password with the uppercase P, etc., right? And so, if an attacker manages to get the list of hashes, it can try to guess passwords. It applies the hash function and check if the hash corresponds to the password. If it corresponds, it gets the password, okay? It's true, the hashing algorithm cannot be inverted, but the point is that you can try to guess the password. And if you start with the ones that have the higher number of hashes that are the same, probably you start from the weakest ones, right? And so what is typically done is adding a randomly generated string to each password before the hashing. And this randomly generated string, which is called salt, like the one you add to the salad when you eat, it's a string which is stored in clear text, in the database. But you see that at this point, even if you have the same password, you get different hashes because you are hashing the password plus the salt. And so an attacker needs to spend a lot more time to check if the password that he or she is guessing corresponds to some hash, because for each user it needs to add the salt. While if you have a list of 1 billion users with the hashes without the salt, you try to hash a password and you can compare it immediately with 1 billion hashes you have. Okay? With the salt, you need to do 1 billion hashes before doing the comparison, one for each user. Okay? So that is important that this will be required for your submission at the exam, because it's important, but I mean, it's not so difficult to achieve because we will see an example. You will have the code that is mostly cut and paste. Okay? But the important thing is to understand why we want to use this strategy. Okay? Because unfortunately, at a certain point, this data will be stolen. Okay? The data on the server, including the data that contains the hashes of the password and so on, will be stolen. So we need to make sure that the attackers cannot easily guess the password that are stored, even if they are stored using hashes. Okay? That's a best practice, and I would say most of the libraries or the website nowadays use this strategy. If they don't use it, probably they are quite bad in terms of security, not just for passwords, okay? Because it really is standard stuff nowadays, okay? So I wanted to leave you with this idea about the fact that passwords needs to be treated very carefully by your application on the server side, okay? But we will give you some advice how to use them, how to store them, and in the best possible way, at least at the moment, okay? You see also there are always links, especially in this part about authentication and the next one, to OWASP, which gives you advice, and these pages get updated over time. So when something important changes, these are updated. So use, refer to these pages when you have doubts or you want to implement something which is, to the best of the current knowledge, is supposed to be secure, okay? So hashing, encryption, explanation, when password hashes can be cracked, and so on, salting. There is also the pepper, but we are not discussing this because it doesn't add too much. Just for curiosity, you can read what is the pepper as well. And all the rest, of course. Okay, so which algorithms are better to do the hash and so on. Don't use a weak algorithm, but it's like encryption and so on. Okay? Okay, so I think I need to finish because of the time. But next time, there will be an example loaded as usual on the course website on GitHub. We will add authentication, so the form will be already prepared, but we will add some parts in the application. And we will see how to store the password, how to establish a session, and so on, and how to use the authentication to achieve our objectives. That means protecting some APIs on the server side. Okay? Okay, if you have any questions, even if you are not from the course, right? That's fine. Otherwise, we'll meet on Monday, right? Okay. Thank you. No questions.